Hello, in this lecture we find out the maximum area of a rectangle that is inside a triangle. In the drawing we have triangle ABC. Side AB of triangle ABC equals to 10 units in its length. Side AC equals to 17 units in its length. Side BC equals to 21 units in its length. Inside this triangle ABC we have this rectangle PQST, and our mission is to find out the maximum area of this rectangle PQST. So the first step, we do construction, that is to say from point A we do perpendicular on PQ. Again from point A we do perpendicular on PQ. So actually this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and side PQ. This point is point M. In the next step, we'll extend the perpendicular AM by a straight line until it touches side BC. And we define the touching point of the extended perpendicular AM and side BC. This point is point N. Actually, by doing this construction, we can get here two corresponding angles. Those two corresponding angles, they are located between the parallel lines PQ and BC, and therefore they are equal to each other according to the rule that corresponding angles between parallel lines are equal to each other. But this angle equals to 90 degrees, therefore this angle must be also equal to 90 degrees because of the fact that those two angles they are equal to each other. Likewise, those two angles they are also defined as corresponding angles, and they are located between the same parallel lines QP and BC, and therefore they are equal to each other. But this angle equals to 90 degrees, therefore this angle must be also equal to 90 degrees according to the same rule. In the next step, we define the length of this line segment as x. So BN equals to x according to our definition. So what is the length of this line segment NC? From the drawing it is very easy to see that NC equals to BC minus BN. Again, NC equals to BC minus BN. So write it down. NC equals to BC minus BN. So NC equals to BC. BC is 21 according to what is given as the question. Minus Bn. Bn equals to x according to our definition. So in total, NC equals to 21 minus x. So here, this is line segment NC. This is equal to 21 minus x. In the next step, I'll copy this right triangle ABN in a new page, and we implement on this right triangle ABN the Pythagoras theorem. According to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is the abbreviation for Pythagoras theorem. side NB equals to x according to our definition. The hypotenuse AB equals to 10 units in its length according to what is given as the question. So actually, this is the right angle triangle A and B that are copied from the original drawing. In this right angle triangle A and B, according to the Pythagoras theorem, AB square equals to BN square plus AN square. Again, AB square equals to BN square plus AN square. So write it down. This will be equation 1. AB square, that is the square of the hypotenuse, equals to BN square plus AN square. So here we subtract BN square from this equation 1, and we get that according to this equation 1, AN square equals to AB square minus BN square. And again, according to equation 1, we should find out that AN square equals to AB square minus BN square. So AN square equals to AB square. AB is 10, therefore AB square is 10 squared, that is 100, minus BN square. BN is x, therefore BN square is x squared. So in conclusion, according to equation 1, we should find out that AN square equals to 100 minus x squared. In the next step, I'll copy this right angle ANC in a new page and we'll implement on this right angle ANC the Pythagoras theorem. Here by PT is the progression for Pythagoras theorem. Side NC equals to 21 minus x. According to what we have already found out. The hypotenuse AC equals to 17 units in its length. So actually, this is the right angle ANC that I copied from the original drawing. According to the Pythagoras theorem, in this right angle ANC, AC square equals to NC square plus AN square. So write it down. It will be equation 2. So AC square AC square equals to NC square plus AN square. Here we subtract NC square from this equation 2, and you get that according to this equation 2, AN square equals to AC square minus NC square. So AN square equals to AC squared. AC is 17, therefore AC squared is 17 squared, that is 289 minus NC. NC is 21 minus X, therefore NC squared is 21 minus X squared. So according to equation 2, we can find out that AN squared equals to 289 minus 21 minus X squared. This is according to equation 2, while according to equation 1, we have only found out that AN squared equals to 100 minus X squared. So we have two different equations from the value of AN squared. Therefore, we get equation 3 that states that AN squared, according to equation 1, must be equal to AN squared according to equation 2. So AN squared according to equation 1 equals to 100 minus X squared, and it must be equal to AN squared according to equation 2. AN squared according to equation 2 equals to 289 minus 21 minus X squared. So according to equation 3, we can find out that 100 minus X squared, that is AN squared according to equation 1, equals to 289 minus 21 minus X squared, that is AN squared according to equation 2. So here we open the brackets of this expression 21 minus X squared, and we get that according to this equation, equation 3, (100 minus X squared) equals to 289 minus, and here 21 minus X squared equals to 21 squared, that is 441, plus X squared minus 2 times 21 times X. 2 times 21 is minus 42. So in total, this expression equals to minus 42x. So according to equation 3, we actually found out that (100 minus X squared) equals to 289 minus, inside the brackets we have 441 plus X squared minus 42x. Here we open the brackets on this side of this equation, equation 3, and finally we get that according to this equation, equation 3, 100 minus X squared equals to 289. Here we'll open the brackets. After we open the brackets, we'll have here minus 441 minus X squared, and minus times minus is plus, so it is minus 42x is plus 42x. So according to equation 3, we actually found out that 100 minus X squared equals to 289 minus 441 minus X squared plus 42x. So here we have minus X squared on both sides of this equation, equation 3, therefore minus X squared will get cancelled. After we cancel minus X squared, in this side of the equation 3, we have only left with 100. On the other side of the equation 3, we have here 289 minus 441 plus 42x. Here we let 441 to this equation, equation 3. And we get that according to this equation, equation 3, 100 plus 441 equals to 541. And it is equals to 289 plus 42x. Here we subtract from this equation, equation 3, 289, and we get that according to this equation, equation 3, 500 41 minus 289 equals to 252. So 252 equals to 42x. Here we divide this equation 3 by 42. And we get that according to this equation 3, x equals to 252 over 42 equals to 6. Again, 252 over 42 equals to 6. So x equals to 6 units in its length. So actually, line segment BN, line segment BN is equal to x is equals to 6 units in its length. And here, this is line segment NC, that is equal to 21 minus x, and x is 6, so it is 21 minus 5, it is 15. In the next step, we return to equation 1. According to equation 1, an squared equals to 100 minus x squared, and x equals to 6, therefore x squared is 6 squared, that is 36. So in total, an squared equals to 100 minus 36, that is 64. So an squared equals to 64. Here we take a root out of this equation 1, and finally we get that an equals to the square root of 64, that is 8. So an equals to 8 units in its length. This is line segment an. Again, this is line segment an. That equals to 8 units in its length. So I write it down here. an equals to 8 units in its length. In the next step, we define the width of this rectangle PQST. The width QS SB, and we define the length PQ of rectangle PQST as A. Here PQ, the length PQ of rectangle PQST equals to A units. So it is given us the question that PQST is a rectangle, and we know that all the angles inside any rectangle are right angles. And therefore, this angle equals to 90 degrees, and this angle also equals to 90 degrees in rectangle PQST. In the next step, we focus on this quadrilateral MQSN. Inside this quadrilateral MQSN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral MQSN, we have 4 right angles, and according to rule 6, any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to this quadrilateral MQSN as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle, in the small rectangle MQSN, side QS must be equal to the opposite side MN. But QS is B, therefore MN must be also equal to B. So what is the length of line segment AM? From the drawing, it is very easy to see that AM in total equals to AN minus MN. Again, AM equals to AM equals to AN minus MN. So write it down. AM equals to AN minus MN. So AM equals to AN, that is 8, minus MN, we just write down further that MN equals to B. So in total, AM equals to 8 minus B. AM equals to 8 minus B, so write it down here. AM equals to 8 minus B in its length. Here, those two angles, here those two angles are defined as corresponding angles, and they are located between the parallel lines PQ and BC, and therefore they are equal to each other. So if this angle is alpha, then this angle must be also equal to alpha, because those two angles are equal to each other. Likewise, those two angles are also defined as corresponding angles, and they are located between the same parallel lines PQ and BC, and therefore they are equal to each other. So if this angle is beta, then this angle must be also equal to beta, because of the fact that those two angles are equal to each other according to the rule that I already mentioned, that corresponding angles between parallel lines are equal to each other. So in the next step, we'll prove that the big right triangle ABC is similar to this small. The big triangle ABC, it is not a right triangle. The big triangle ABC is similar to this small triangle APQ. So why the big triangle ABC is similar to the small triangle APQ? Actually, we know that if you have two similar triangles, then the ratio between their heights is equal to the ratio between their sides. That is to say, the ratio between their corresponding heights must be equal to the ratio between their corresponding sides. Okay, so, but before that, we will prove that the big triangle ABC is similar to the small triangle APQ. So write those two right triangles. Write the big triangle ABC is similar to the small triangle APQ. The reason is that because of the fact that those two angles are both equal to alpha, they are equal to each other. In addition, those two angles are both equal to beta, therefore they are equal to each other. And finally, this angle A, is a common angle that belongs to both triangles, so angle A equals to itself as a common angle that belongs to both triangles. So I found out that all the three angles in the big triangle ABC are correspondingly equal to all the three angles in the small triangle APQ. Therefore, the big triangle ABC is similar, this is the sign of similar, to the small triangle APQ, according to angle similarity rule. and from the fact that the big triangle ABC is similar to the small triangle APQ. So I mentioned before, when you have two similar triangles, the ratio between corresponding heights must be equal to the ratio between corresponding sides. That is to say, here the height AM in the small triangle APQ over the height AN in the big triangle ABC must be equal to the ratio between side PQ of the small triangle APQ over side BC of the big triangle ABC. Again, this equation means that the ratio between the corresponding sides of the two similar triangles, triangle ABC and triangle APQ, must be equal to the ratio between their corresponding sides. Okay, so AM over AN equals to PQ over BC. We already found out that AM equals to 8 minus B over AN. AN equals to 8. And it is equals to PQ. PQ equals to A according to our definition. It is actually the length of rectangle PQST, and it is equals to A according to our definition, over BC. BC equals to 21 units according to what is given as the question. So in conclusion, actually found out that according to equation 1, 8 minus B over 8 equals to A over 21. Here we cross multiply this equation 1. So we get that according to this equation 1, 8A equals to 21 times 8 minus B. So here we open the brackets on this side of this equation 1, and we get that according to this equation 1, 8A equals to, actually we divide this equation 1 by 8, and we get that according to this equation 1, A, that is the length of rectangle PQST, is equals to 21 over 8 times 8 minus B. This is according to equation 1. Again, A equals to 21 over 8 times 8 minus B. Here we'll open the brackets on this side of this equation 1. And we get that according to equation 1, A equals to, here 21 times 8 over 8 is 21. And here we have 21 over 8 times minus B equals to 21 to minus 21B over 8. So according to equation 1, we actually found out that A equals to 21 minus 21B over 8. So here we'll multiply this equation 1 by B. B is the width of this rectangle PQST, and we get that according to equation 1, A times B is AB, so AB equals to 21B, and here minus 21B over 8 equals to minus 21 over 8 B squared. So we found out that according to equation 1, A times B equals to 21B minus 21 over 8 times B squared. A is the length of rectangle PQST, and B is the width. And the length times the width if there is the area of this rectangle PQST. That is the area that we are looking for. So if we found out that the area of rectangle PQST, that is 8 times B, is equals to 21B minus 21B squared over 8. Repeat again that our mission is to find out the maximum area of this rectangle PQST. And the area of rectangle PQST, that is actually 8 times B, is dependent on the variable B, the independent variable B. So actually, our mission is to find out the maximum value of this function, that is to say the maximum area of the function, because AB is the area. Our mission is to find out the maximum area of the maximum value of this function, that is the area function. So for which B, that is the width of this rectangle PQST, for which B, the area AB will be at its maximum value. Or in other words, we have to find out the extreme point of this area function, AB equals to 21B minus 21 over 8 times B squared. In order to find out the extreme point of this area function, we'll differentiate this area function and then we'll equate the derivative to 0. In this way, we'll find out the extreme point or the extreme points of this area function. And after we found the extreme point, actually the extreme point could be minimum extreme point. So it might be the minimum area of this rectangle PQST, but it might be also the maximum extreme point, and the maximum extreme point is the area that we are looking for. But in order to verify that we found that the extreme point that we found is the maximum extreme point, we will have to draw the area function of this rectangle PQST, and by looking at the graph of the area function of rectangle PQST, we can easily say if the extreme point is the maximum point or the minimum point. Whether if it is the maximum extreme point, that is the maximum area of this rectangle PQST, or it is the minimum extreme point. That is to say, it is the minimum area of this rectangle PQST. So in the first step, we'll differentiate this area function. So D is the ratio for derivative. So we take the derivative of function of the area function, that is actually 21b minus 21 over 8 times b squared. And we will differentiate it by according to the b variable. The b, the independent variable, that this area function is composed of only with b, that is the independent function of this area function, and a times b, that is the area itself, is the dependent function, the dependent value. So we differentiate this area function according to the independent variable, that is b. b is the width of this rectangle PQST. So what is the derivative of 21b? And after we took the derivative, we equate the derivative to 0 in order to find out the extreme points of this area function. AB equals to 21b minus 21 over 8 times b. Again, we have to equate this derivative to 0 in order to find out the extreme points of this area function. So what is the derivative of 21b? The derivative of 21b, it's actually, we know that the derivative of b is 1. So in total, this the value of 21b after we differentiate this expression will be equal to 21 times 1, that is 21. That is to say, the derivative of 21b is 21 minus the derivative of this expression 21 over 8 times b squared. So it's actually minus 21 over 8, and the derivative of b squared is 2b. So in total, the derivative of minus 21 over 8 b squared equals to minus 21 over 8 times 2b. Repeat again. The derivative of 21 over the derivative of minus 21 over 8 times b squared equals to minus 21 over 8 times 2b, and it is equal to 0. So here we take 21 as a common factor out of those two expressions, and we get that. So 21 is taken out as a common factor out of those two expressions. So what is left from 21 after we took 21 as a common factor? What is left is 1. And what is left from this expression minus 21 over 8 times 2b after we took from it 21 as a common factor? What is left is actually minus 2b over 8 equals to 0. So we found out that according to equation 2, 21 times 1 minus 2b over 8 equals to 0. Here we divide this equation 2 by 21. And you get that according to this equation 2, 21 over 21 is 1. So in this side of the equation we left only with 1 minus 2b over 8. And it is equals to here 0 over 21 is 0. So in conclusion, according to equation 1, we actually found out that 1 minus 2b equals to 0. Here we add minus 2b, 1 minus 2b over 8 equals to 0. Here we add minus we add 2b over 8 to this equation 2. And we get according to this equation 2, 1 equals to 2b over 8. So here we divide both the numerator and the denominator of this expression by 2. And we get that according to this equation 2, 1 equals to 2b over 2 is b, and here 8 over 2 is 4. So in conclusion, according to equation 2, we found out that 1 equals to b over 4. Here we multiply this equation 2 by 4, and finally we get that b equals to 4 units in its length. So we found out that the extreme point of this function area AB equals to 21b minus 21b squared over 8. The extreme point is b equals to 4. Again, the extreme point of this function area is b equals to 4. Now we have to verify that the extreme point that we found is maximum extreme point and not minimum extreme point. In order to verify that b equals to 4 is maximum extreme point and not minimum extreme point, I draw the function area of this rectangle PQST. The function area of this rectangle PQST. So this is the area function, the graph of area function of rectangle PQST. In the y-axis we have the area, and in the x-axis we have the width B. And it is very easy to see that when B equals to 4, the area is at its maximum value. It is above, a little bit above 40 square units here. This point is located above 40 square units. This number is 40. Therefore, we found out that B equals to 4 is maximum extreme point of this function area, is not minimum. Okay, now in order to find out what is the maximum area of this rectangle PQST when B equals to 4, we have to put the value of B equals to 4 inside the function area in order to find out the maximum area of this rectangle PQST, that is the area that we are looking for. So the function area of this rectangle PQST is A times B, that is the area of rectangle PQST, and A times B equals to 21B minus 21 over 8 times B squared. Here we substitute B by 4. In this way we find out the area AB of this rectangle PQST when B equals to 4. And we already found out that when B equals to 4, the area is at its maximum value. And therefore, this will be the answer to the question. When we find out the area of this rectangle PQST when B equals to 4, the width B equals to 4 units. So the area AB equals to 21B, and B is 4, so we substitute B by 4. So it is 21 times 4 minus 21 over 8 times B squared. B is 4, therefore B squared is 4 squared, it is 16. So we found out that the maximum area AB of this rectangle PQST is equals to 21 times 4 is 84, and here we have 16 over 8 is 2, so in total this expression equals to minus 21 times 2, that is minus 42. So we found out that the maximum area of rectangle PQST equals to 84 minus 42, that is 42. Okay, so the maximum area of this rectangle PQST that is located inside this triangle ABC is equal to 42 square units. And that is the answer to the question. By the way, when the width B equals to 4, then the length PQ equals to 10.5. Okay, so as it on, when B equals to 4, the length A equals to 10.5. B times A is the area, so B is 4, the length A is 10.5, and 4 times 10.5 is 42 square units. It's actually the maximum area of this rectangle PQST. Okay, so in the next step I will summarize the lecture. In this lecture, we found out the maximum area of this rectangle PQST that is located inside triangle ABC. So in the drawing we have triangle ABC. Side AB of this triangle ABC equals to 10 units in length. Side AC equals to 17 units in length. Side BC equals to 21 units in length. Inside this triangle ABC we have this rectangle PQST, and our mission is to find out the maximum area of this rectangle PQST. So first of all we did the construction, that is to say from point A we do perpendicular on PQ. Again from point A we do perpendicular on PQ. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A in PQ, this point SM. Then we extended the perpendicular AM by side line until it touches side BC, and we define this touching point as N. So here we have, by doing this construction, we can adhere two corresponding angles. Those two angles are defined as corresponding angles, and they are located between the parallel lines PQ and BC, and therefore they are equal to each other. So those two angles are equal to each other. But this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees. Likewise, those two angles are also defined as corresponding angles, and they are located between the same parallel lines PQ and BC, and therefore they are equal to each other. But this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees. In the next step we define the length of this line 7BN as x, and therefore NC equals to BC minus BN. That is to say NC equals to BC, that is 21, minus BN, that is x. So in total NC equals to 21 minus x. In the next step I copied this right triangle ABC in the page and implemented the Pythagoras theorem in this right triangle ANB. According to the Pythagoras theorem, in a right triangle, the square of the opposite equals to the sum of the slopes of the perpendiculars. So this is the right triangle A and B that are coming from the original drawing. The opposite AB equals to 10 units, according to what is given in the question. According to our definition, sine Bn equals to x. So in this right triangle A and B, AB square equals to Bn square plus An square. AB is 10, therefore we did actually later here. So we subtracted Bn square from this equation 1, and found out actually that An square equals to AB square plus Bn square. So An square equals to AB square. AB is 10, therefore AB square is 10 squared, that is 100, minus Bn square. Bn is x, therefore Bn square is x square. So according to equation 1, we actually found out that An square equals to 100 minus x square. In the next step, I copied this right triangle A and C in a new page, and we implemented the Pythagoras theorem in this right triangle A and C. So actually, this is the right triangle A and C that are coming from the original drawing. The opposite AC equals to 17 units in step, according to what is given in the question. NC, side NC equals to 21 minus x. So according to the Pythagoras theorem, in this right triangle ANC, AC square equals to NC square plus AN square. Again, AC square equals to NC square plus AN square. Here we subtracted NC square from this equation 2, and finally found out that AN square equals to AC square plus NC square. AN is the missing side, so we leave it as it is. So AN square, here we subtracted NC square from the equation, and finally found out that AN square equals to AC square minus NC square. AC is 17, therefore AC square is 17 squared, that is 289, minus NC square. NC is 21 minus x, therefore NC square is 21 minus x square. So according to equation 2, I found out that AN square equals to 289 minus 21 minus x square. This is according to equation 2, but according to equation 1, we already found out that AN square equals to 100 minus x square. So we have two different equations for the value of AN square. Therefore, we get equation 3 that states that AN square according to equation 1 must be equal to AN square according to equation 2. AN square according to equation 1 equals to 100 minus x square, and it must be equal to AN square according to equation 2. AN square according to equation 2 equals to 289 minus 21 minus x squared. Here we open the brackets of this expression, 21 minus x squared, and we found out that according to this equation 3, 100 minus x squared equals to 289 minus, and 21 minus x squared equals to 21 squared, that is 441, plus x squared minus 2 times 21 times x is minus 42x. Here we open the brackets of this expression and found out actually that 100 minus x squared equals to 289, and after we open the brackets, this expression will be equal to minus 441 minus x squared, and here minus times minus is plus. This is plus 42x. So here we have x squared on both sides of the equation. 3, therefore x squared will get cancelled. After we cancel x squared, this side of this equation 3 we left only with 100. On the other side of the equation 3 we have 289 minus 441 plus 42x. So according to equation 3, 100 equals to 289 minus 441 plus 42x. Here we added 441 to this equation 3, and finally found out that according to this equation 3, 100 plus 441 equals to 541. And the other side of the equation we have 289 plus 42x. So according to equation 3, we actually found out that 541 equals to 289 plus 42x. Here we subtract 289 from this equation 3, and finally found out that 549 minus 289 equals to 252. So 252 equals to 42x. Here we divided this equation 3 by 42, and finally found out that x equals to 252 over 42. So 252 over 42 is x. So x equals to 6 units in its length. So this line 7bn is equal to x equals to 6, and this is line 7nc, that is equal to 21 minus x, that is to say it is 21 minus 6, that is 15. The next step we return to equation 1. According to equation 1, an squared equals to 100 minus x squared. And x is 6, therefore x squared is 6 squared, that is 36. So in total, according to equation 1, an squared equals to 100 minus x squared, and x squared is 36. So in total, according to equation 1, an squared equals to 100 minus 36, that is 64. So according to equation 1, we actually found out that an equals to 64. Here we took all of this equation in equation 1, and finally found out that an equals to the square root of 64, that is 8. So an equals to 8 units in itself. This is line 7 an, is equals to 8 units in its length. In the next step, we define the width QS of this rectangle PQSN SB, and we define the length of this rectangle PQST SA. That is to say, the length PQ equals to A and the width QS equals to B according to our definition. And here we have those two angles, they are defined as corresponding angles, and they are located between the two parallel lines PQ and BC, and therefore they are equal to each other. So if this angle is alpha, then this angle must be also equal to alpha. Likewise, those two angles are also defined as corresponding angles, and they are located between the two same parallel lines PQ and BC. According to the rule that I mentioned, that corresponding angles between parallel lines are equal to each other, those two angles must be equal to each other. So if this angle is beta, then this angle must be also equal to beta. The next step, I proved that the big triangle ABC is similar to the small triangle APQ. So why those two triangles are similar to each other? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to beta, therefore they are equal to each other. And finally, this angle A, is a common angle that belongs to both triangles. So we can write down that angle A equals to itself is a common angle that belongs to both triangles. So actually found out that all the three angles of the big right triangle ABC are correspondingly equal to all the figures of the small right triangle AQP, and therefore those two triangles are similar to each other according to angle similarity rule. And again, the big triangle ABC is similar to the small right triangle APQ according to angle similarity rule. And whenever you have two similar triangles, then the ratio between their heights must be equal to the ratio between their sides. Or, in other words, the ratio between their corresponding heights must be equal to the ratio between corresponding sides. In those two similar triangles, that is to say, the big triangle ABC and the small triangle APQ, it means that the height AM in the small triangle APQ over the height AN in the big triangle ABC, that is the ratio between the corresponding heights, must be equal to the ratio between the corresponding sides. That is to say, the ratio between side PQ of the small right triangle APQ or the ratio over side BC of the right triangle ABC, or of the big triangle ABC. So in conclusion, we found out that because of the fact that the big triangle ABC is similar to the small triangle APQ, that AM over AN, that is the ratio between the corresponding heights of the two triangles, of the two similar triangles, must be equal to PQ over BC. That is the ratio between the corresponding sides of the two similar triangles. So, according to equation 1, we found out that AM over AN equals to PQ over BC. If AM equals to AN minus MN. Again, AM equals to AN minus MN. Repeat again. So, AM equals to AN minus MN. So, AM equals to AN, that is 8, minus MN, that is B. So, in total, AM equals to 8 minus B. Therefore, we can substitute AM by 8 minus B over AN is 8. PQ is A according to our definition, and BC is 21 according to what is given as the question. So in conclusion, we found out that according to equation 1, 8 minus B over 8 equals to A over 21. Here we cross multiply this equation with equation 1, and finally found out that 8 times A equals to 21 times 8 minus B. So here we divided this equation 1 by 8, and finally found out that according to equation 1, 8A over A is A, so A equals to 21 over 8 times 8 minus B. So here we open the brackets on this side of this equation 1 and found out that according to this equation 1, A equals to 21 over 8 times 8 is 21, and here 21 over 8 times minus B equals to minus 21B over 8. So according to equation 1, we found out that A, that is the length of rectangle PQST, the length A equals to 21 minus 21 over 8 times B. Here we multiply this equation 1 by B, and finally found out that according to this equation 1, A times B is AB, and it is equals to 21 times B, that is 21B, minus 21 over 8 times B is minus 21 over 8 times B squared. So according to equation 1, we found out that A times B equals to 21B minus 21 over 8 times B squared. A is the length of this rectangle PQST, and B is the width. And the length times the width equals to the area of this rectangle PQST. Therefore, A times B is the area of rectangle PQST, and the area equals to, according to this equation 1, the area of rectangle PQST, that is A times B, equals to 21 times B minus 21 over 8 times B squared. So the area is the dependent variable, and B, the width, is the independent variable. By determining the value of B, we determine the value of the area. Okay. So we found out that the area of rectangle PQST, that is 8 times b equals to 21b minus 21 over 8 times b squared. Our mission is to find out the maximum area of this rectangle PQST. And we already found out that the area equals to 21b minus 21 over 8 times b squared. So actually our mission is to find out the maximum value of this area function. Okay, so for which b, the value of this function, that is to say 8 times b, that is the area of this rectangle PQST, for which b, the value of AB will be at its maximum value. In order to find out the answer to this question, we actually differentiate this function area. We took the derivative of this function area and then we equate the derivative to 0. So we differentiate this function area and we equate the derivative to 0. So what is the derivative of 21b? The derivative of 21b is 21 because the derivative of b is 1 and 21 times 1 is 21 minus 21 over 8 times b squared. What is the derivative of minus 21 over 8 times b squared? The derivative of b squared is 2b, and therefore after we took the derivative of this expression will be equal to minus 21 over 8 times 2b. So in conclusion, we found out that the derivative of this function area equals to 21 minus 21 over 8 times 2b. And we must equate the derivative to 0 in order to find out the extreme point or points of this function area. But the extreme point could be minimum extreme point or maximum extreme point. That is to say, the point that we found after we equate this derivative to 0, it might be the minimum area of this rectangle PQST, or it might be the maximum area of this rectangle PQST. Okay, and the way to know whether if the extreme point that we found is a minimum extreme point or maximum extreme point, we have to draw the function area, and from the graph of the function area we can definitely say if the extreme point is a minimum extreme point or maximum extreme point. Okay, so we solve this. We equate this derivative to 0. This way we found the extreme point of this function area. So here we have 21 minus 21 over 8 times 2b. We took 21 as a common factor out of these two expressions, so what is left from 21 after we took from it 21 as a common factor, what is left is actually 1. And what is left from this expression after we took from it 21 as a common factor, what is left is actually minus 2b over 8. So if we according to equation 2, we found out that 21 times 1 minus 2b over 8 equals to 0. Here we divided this equation 2 by 21. So in this side of the equation we have 21 over 21 is 1, so we left only 1 minus 2b over 8. And the other side of the equation we have 0 over 21 is 0. So according to equation 2, we actually found out that 1 minus 2b over 8 equals to 0. Here we added 2b over 8 to this equation 2, and finally found out that 1 equals to 2b over 8. So here we divided both the numerator and the denominator of this expression by 2. We found out that 2, according to equation 2, 1 equals to 2b over 2 is b, and 8 over 2 is 4. So we found out that according to equation 2, 1 equals to b over 4. Here we multiply this equation 2 by 4, and finally found out that b equals to 4 units in strength. So here actually the extreme point of this function area of this function area of rectangle PQST, the extreme point is b equals to 4. Now we have to draw the function area in order to verify that the extreme point b is equal to 4. It is indeed the maximum extreme point and not the minimum extreme point. So actually, this is the function area of rectangle PQST. The y-axis is the area. In the y-axis we have the area. In the x-axis we have the width b. You can definitely say that here that if b equals to 4, then the area is its maximum value or its maximum height. The area is a little bit more than 40 square units. Here this number is 40, so the area is a little bit greater than 40 square units. And therefore, actually, in this way, we should verify that the extreme point b equals to 4 is indeed maximum extreme point and not minimum extreme point. And therefore, the question is that when b equals to 4, we have the maximum area of this rectangle PQST. In order to find out what is the maximum area of this rectangle PQST, we just have to put in the area function the value of b equals to 4. In this way, we find out what is the area, what is the maximum area when b equals to 4 units in Islam, which b equals to 4 units. And again, the area function of this rectangle PQST is equals to 21 minus 21 over 8. The area function is equals to the area function AB equals to 21b minus 21 over 8 times b squared. Now we have to substitute b by 4, because b is the maximum extreme point of this rectangle PQST. So we substitute b by 4 in this function area. So the maximum area will be equal to 21b, and b is 4. So we substitute b by 4. So it is 21 times 4 minus 21 over 8 times b squared. B is 4, therefore b squared is 4 squared, that is 16. So in total, we found out that the maximum area of this rectangle PQST equals to 21 times 4 minus 21 over 8 times 16. 21 times 4 is 84, and here minus 21 over 8 times 16. 16 over 8 is 2. So in total, this expression equals to minus 21 times 2, that is minus 42. So in conclusion, we found out that the maximum area of this rectangle PQST equals to 21 minus 42, that is 42. Repeat again, we actually found out that the maximum area of this rectangle PQST is equals to 42 square units. And when the area equals to 42 square units, then the width of this rectangle PQST b equals to 4, and the height equals to 10.5. The length equals to the length A equals to 10.5. How do we know that the length equals to 10.5? We just have to put the value of b in the equation of A. Here we have the equation for A. According to equation 1, we can find out that the length A equals to 21 minus 21 over 8 times b. And we just have to substitute b by 4, and we get that A equals to 21 minus 21 over 8 times 4. And this expression will be equal to 10.5. So actually found out that when the area of this rectangle PQST equals to 42 square units, that is its maximum area. Then the width B equals to 4 and the length A equals to 10.5. And the width times the length is 4 times 10.5, that is the area 42. That is actually the maximum area of this rectangle PQST. Repeat again, the maximum area of this rectangle PQST is equal to 42 square units. Okay, thank you very much.